All right, sorry, I got cut off there, guys. Once you put, so what's going on here is I've ordered CB and BC together. So now once they're together, I have 1, 2, 3, 4, 5, 6, and then the group here, 7 elements. So I want to line up the 7 elements. So they can't be broken up. So think of this. This is one guy. This is another guy. That's another guy. That's another guy. That's another guy. That's another guy. And this is like another guy. Okay, it's the 7th guy. Okay, so that's another element. So it becomes 2 factorial times 7 factorial because I got to line these guys up. So line up these 2 groups, C and B, B, C. And then at that point, I have not 8 groups. I have 6 small groups, 1 larger group. That's 7 groups. Okay, and I have to line up these 7 elements together. So that's the number of ways to do that. And I think the question asks about probability or the number of ways. Hold on. Let me go back to the actual question for 1 second here. Hold on. Yeah, it says probability that 2 and 3 will go one after another in order. So the probability would then be 2 factorial, 7 factorial. That's the number of ways we can do that over the original total number, which is 8 factorial. Okay, so that's that answer. The number of ways that it doesn't happen, the probability that it doesn't happen would be 1 subtract that. That's how I would do it. Okay, I would say this is the 100% of the time something happens. If what we're looking for isn't going to happen, we subtract the probability that it does happen from there to get the other one. So again, this is 1 subtract PA, the probability of an event happening, is equal to the probability of the event not happening. Okay, so that is that. Let's go back to your content here. Excuse me. Keep going through that again. So they did that one this way. It's kind of funny. They did it the same way. Permutations. If you want to go permutations, there's this thing here, and we'll get into permutations in 1 second. So the number of ways to order. So far we've been ordering all the elements, right? But sometimes you don't order all the elements. So what that is called a permutation. So order matters. In the next lesson, order won't matter. So what is happening here is you have a question where the number of arrangements, let's just go over some of these here. You're going, out of 20 students, 6 were randomly selected to present the first day. What's the probability? Blah, blah, blah. So how many ways? Let's just answer this question. Let's take a look at this question together. Give me 1 second. So I'm going to just see if I can cut and paste this. Here. Okay. Copy and paste. Let's see if this works. All right. Paste. Yes, when doing a presentation in class, students had a choice to either present a fictional story or a nonfiction story. 12 students chose fiction, 8 chose nonfiction. Of the 20 students, 6 were randomly selected to present the day. What's the probability that they were selected in alternating order? Blah, 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 blah. So the word order comes in. So that means order matters. That means it's a permutation. Next unit is called combinations. Order doesn't matter. But let's leave that for now. So what we have is we have 20 kids. 6 are chosen. Okay, so we have 20 kids. 6 are chosen. 12 chose fiction. 8 chose nonfiction. And the question is, what's the chance that it goes fiction, nonfiction, fiction, nonfiction, nonfiction, blah, 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 blah. We'll get to that in 1 second. What I want to do first is, in any probability, what you have to do is find out the total number of ways to do something. So we have 20 students, and we're going to take 6 of them and put them in order. So when we look at that, we can look at the slot method for that to start off with. Okay, so if I said choose 20 students and put them in order, how many ways can I do that? You would say I have this many ways to do it. Okay, and you'd multiply each of these together. There's another way to write that. Okay, this is not 20 factorial because it stops here. Okay, but there's another way to write that, and that is 20p6. So that's a permutation. So what we're doing is we're taking 20 elements and we're choosing just 6 of them and putting them in order. That guy is equal to 20 factorial. So what you do is you take this number, that's the top, over, okay, not 6 factorial, but 20 subtract 6 factorial. So that's going to be equal to 20 factorial over 14 factorial. Okay, and then I'm going to expand that to show you how this works. 20 factorial is equal to 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13, blah, 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 blah. Keep going, right? Okay, I just did that on purpose. And this, the 14 factorial is 14 times 13, dot, 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 dot. Okay? And if you look at this, what happens is you can cancel stuff out. there's a 14, there's a 14, there's a 13, there's a 13. And you can cancel all this, cancels out with this. So what are you left with? You're left with 20 times 19 times 18 times 17 times 16 times 15, which was what we did in the slot method. Okay? Another way to think of that with cancellation is once you start going here 19, 18, 17, 16, 15. Now, I'm going to then write 14 in every number multiplied by every number after that, which is actually 14 factorial. Think about that, right? 14 times 13 times 12 all the way down is 14 factorial. And on the bottom, I had 14 factorial. And these guys will cancel out. You're left with that. So that's how you write a permutation. And the question is, how many ways can you do it so this happens or that happens? And what you do is you actually figure out how many ways this can happen or how many ways that can happen. And you could use the slot method for that. So what I would do here is I would have, I'm looking at this and I go like this for the first case. I have six slots. And if I'm going to go fiction, let me get this straight. Fiction is 12. So I have 12 options for this spot, 11 options for this spot, 10 options for this spot, right? I take a fiction book, a fiction book, a fiction book, and then I'm going to go nonfiction. And I'm going to go 8 options for this, 7 because there's 8, and then 6. That's the number of ways I can go fiction, nonfiction, fiction, nonfiction. And then what we do when you have or is you're going to look at the cases. That's case 1 is this, case 2 is this, and it's going to be the same thing. It's just going to be in a different order. You're going to go 8 for the first spot, 7, then 6, and then I'm not going to change colors, 12, 11, 11 and 10. And there's many ways to write that, right? There's different ways to write that. You could even write them as permutations if you like. But what you do is you have that, and you add them together. And that's how you get the solution. So if we look at the solution that they had here, what they did is they looked at case 1, and they did it with permutations, but you don't have to, okay? You can use whatever you have to use, permutations or slot method. That's that. Case 2 is the same thing, 12p3 and 8p3, right? So 12p3 is this, 12, 11, and 10. 8p3 is the 8, 7, 6. Sorry, guys, my computer just died, but I think we're good. So that's case 1 and case 2, and then you add them together, and that will give you the numerator for your fraction. So where'd that go? So case 1 and case 2 added together, that's your numerator. Your denominator we already got, that's 20p6, and you could put that in a calculator to get 3.2%. And that's about it. Just work on the other stuff here. Kind of tricky, I think. Permutations are tricky, but hopefully that's enough practice for you. If not, if you want more practice, send me an email and I can come up with some stuff. All right, take care. Bye.